Very warm welcome to you all. Thank you particularly to our speakers, Mick Storr from CERN, Claire Harvey from SEPNet and Elizabeth Cunningham from STFC. That's very, very kind of you to take the time. And also to all the others. I think we've got about 14 people on the call at the moment, so it's great to have you all there. So just a few things in terms of conference call etiquette. For those of you who've not been on one before, it's quite tricky because you can't tell when to speak or when somebody else will speak. Firstly, could I ask if you need to cough or if there is noise in your background, if you could minimise this, because otherwise we'll all hear it quite loudly. And secondly, if you do need to leave the call, do tell us, because the call will announce that you've sloped off. So do say. But otherwise, just speak as normal and don't, you will all interrupt occasionally. That will be fine. So I'm going to hand over in a moment to Michaela, who will share the detail of the call. But first of all, I'd like to just sort of go round the table, as it were, so you can all hear who is on the call. And if you can just say who you are and where you're from, that would be great. So I'll start with myself. I'm Penny Fiddler. I'm the Chief Executive of the UK Association for Science and Discovery Centres, and also the Director of the Explore Your Universe programme. And Michaela?
Yeah, I'm Michaela Livingston. I'm the Special Projects Manager for ASDC, and I'm managing Explore Your Universe.
Great stuff. Elizabeth Cunningham, do you want to introduce yourself first?
Sure. So I'm Elizabeth Cunningham. I'm the Particle and Nuclear Physics Outreach Officer at STFC, although some of you might have known me in my previous incarnation as Planetarium Astronomer at the Royal Observatory, Greenwich.
Fantastic. Thanks, Elizabeth. And Claire Harvey?
Hi, I'm Claire Harvey from SEPNet, which is the South East Physics Network. We're a consortium of university physics departments in the South East, all working together with our outreach programme.
Thanks, Claire. And we'll share the delegate list afterwards, and we'll also give you each other's email addresses should you want to follow anything up. Mick Storr?
Sorry?
Hi there. Me? Yes.
I only heard half my name. Okay, I'm Mick Storr. I work at CERN, and I'm responsible for the CERN Visit Service and for programs for high school physics teachers.
Thanks, Mick, and thanks for joining us from Switzerland today. Marie Dare from Satrosphere.
Hi there, yes, I'm here.
What's your role in Satrosphere, Marie?
I'm an education officer, and I've been administering a lot of the feedback and things like that for the Explore Your Universe project.
Great, and your colleague from Satrosphere, Peter?
Hi there, yes, my name is Peter. I've recently joined the team up at Satrosphere, and I'm also an education officer.
Thank you. Whoever's coughing, you'll probably need to do it away from the phone. Dynamic Earth?
Hi there, my name's Tiffany. I'm one of the education officers at Dynamic Earth.
Thanks, that's Tiffany Giles. Science Oxford?
Hello, my name is Brian Mackin, and I work at Science Oxford as part of the delivery team, so I do a lot of the actual stuff on the ground.
That's great. And Glasgow Science Centre?
Hi there, my name is Katie Mould. I've just recently joined the Science Learning team as Science Education Coordinator, and I'm responsible for programme development and project management.
Great, and at Bristol?
Hiya, I'm Lee. I'm at Bristol's Planetarium Officer, and we also have...
Hi, I'm Michael Peacock, and I'm a communicator at Bristol, so my job is to basically deliver workshops to our school groups.
Great stuff. And Intech?
Hi, I'm Jenny Shipway. I'm the Planetarium Manager at Intech Science Centre and Planetarium.
Thank you. In Winchester. And Daresbury?
Hi, it's Wendy Cottrell, Public Engagement Liaison Officer at STFC. I'm accompanied by Alan Brown, who is
Education Public Programmes Officer.
Education Public at Daresbury too.
Thank you very much. And do we have Sophie on the call?
You do, yes. Hi. Sophie Allen, physics teacher for the National Space Academy, and I've been working on the development of the Explore Your Universe project.
Thanks, Sophie from the National Space Centre in Leicester. Anybody else that I've missed out? Lovely. So we've got 13 different organisations on the call. You all have various interests in particle physics and communicating particle physics, or maybe some of you are very keen just to learn a little more about it. And we do have some great experts on the line. I'm not one of them, I have to say. I'm a neuroscientist by training. So before I hand over to Michaela, somebody's breathing quite heavily on the line. If you could just desist, that would be great. Marvellous. So I hand over to Michaela to introduce the first of our speakers.
All right. So we'll start off with Mick Storr at CERN. He's introduced himself. Basically, they run a whole bunch of visits where they get students in, and so they deal every day with, trying to explain what it is they do. They have the benefit, of course, of having CERN where they are, so it helps somewhat. But I just thought it would be interesting to maybe hear some stories and examples from Mick and his top tips. So without further ado, I'll hand over to Mick for about 5-10 minutes. Just to say that I think we'll give a couple of minutes for questions after each speaker. So when you're done, speakers, say you're done. But then at the end, we've got quite a fair amount of time just to delve really well into questions. And a lot of you had written down your sort of questions and top tips as well. So we'll make sure we try and get through all of those. So, Mick, would you like to take it away?
Okay, thank you very much for inviting me to participate. I'm feeling slightly challenged because I realize I'm talking to people who have got a lot of experience in promoting science and explaining particle physics to people, but nevertheless I'll just carry on. I decided I would talk about the things that I tell guides, actually CERN guides. Just to put you in the picture, we have 100,000 visitors per year to CERN. 30-40% of those are school groups, and they come from all over the world. This means that we conduct visits in many different languages. In order to do that, we employ, in inverted commas, real scientists and engineers. If you come to CERN, you will actually meet the geek, which is a strong point, but it can also be a weak point, and I'll explain those two things in a minute. So you actually do meet a real scientist, a real engineer, and very often he's given, or she has given, their time freely to this exercise. We do pay them, some of them, if they're not on a CERN contract, or if they're working at weekends and things like that. We give them some training. They're required to go on basic communications review course, and we give them training for safety procedures at the places where they visit, but we more or less leave their content that they deliver up to them, but we guide them through this by requiring them to attend as observer visits of the places that they will actually guide. So it's a combination of communications training, safety training, and listening to their peers, listening to what they do, and then of course asking lots of questions. So usually I start off by telling guides and this is a very, very simple statement, and I usually start off by telling them if there's only one thing that I want you to remember from our little training session together, is that a smile goes an awful long way. And if you can actually meet people with a smile throughout your guided visit, and smile when they go, you will already be onto a good track, because this means that you're feeling good yourself, it means that you're happy to see the people, and it's also a good idea to say thank you when they come. In the details, we ask them to tell something about themselves. Why do we ask that? It's to establish their credibility. People that can then put two and two together and realize that they're not speaking to a professional guide, but they are speaking to somebody who really does know what he or she is talking about. And if they're going to visit somewhere where they work, we say, please tell people that, because it really is a fantastic hook. At the beginning, we also tried to encourage them to give a hook, to explain to people where they're going, what they're going to see, and build up some anticipation, so that the people who in front of you, who are somewhat neutral, because we get visitors from all over the world, from 5 years old to 105 years old, with zero knowledge of science, to maybe a Harvard professor or somebody like this, and a priori you often don't know who is in your group. So we ask them to watch very carefully, look at the people. You will recognize the people who are rather neutral. If it's a school group, they will not be unhappy to be with us, but they may prefer to be down at the lake, or at least they're not unhappy because they would be in a hot classroom in Milano. The idea and the challenge for the guide is to translate these neutral people into feeling positive. And our mission statement, we have a mission statement at CERN, is that everybody should leave CERN well-informed, inspired, curious to know more, and ready to act as an ambassador for science, physics, particle physics, and CERN. Notice science and engineering, not just CERN. How do we guide them to do this? Well, we try to encourage them to go carefully, be simple, keep things simple, don't assume any prior knowledge. If there is some obvious prior knowledge, don't insult the people or patronize them. Use the technique of presenting what you're telling them as a review, rather than saying directly to them. Okay, so it's very important to try to bring everyone on board. No acronyms. If you talk about the LHC, say what it is. Be humble, and of course be enthusiastic. Don't give the impression, especially to school kids, that you are the teacher, that you know everything, and they're not going to understand. Surprisingly enough, this has been an issue with us very, very, very recently from a school that came from Liverpool. But I can tell more about that if somebody wants to know. So, start low. Do not do a core dump of everything that you know about a particular subject, because this will just switch people off. And if possible, pose non-challenging questions to the group. You can find out a lot about at what level you should pitch your description, your visit, just by posing non-challenging questions and looking carefully at the response. Start with the big picture. Try to relate to people's experience. Many people have looked into a microscope and they know that things are made of things that they can't actually see with the naked eye. So then going further than that and saying that the LHC itself is a big microscope is maybe a concept that they can grab. People have looked with telescopes at the stars, and if we want to talk about the universe and the Big Bang and things like this, we can say that people have been looking at stars for many thousands of years. And only the other week I met somebody who is helping to train teachers in Tanzania, and in Tanzania they have stargazers or star experts there who can read the stars and know a lot about the stars, and even people use the stars. The women start cooking when stars are in a certain position in the sky because they know the guys will be home from hunting, things like this. We try to tell them what are the three big questions that CERN is trying to answer, that humankind has been asking for thousands of years. Where do we come from? What are we made of? And where are we going? How did the universe begin? What the universe is made of? And how is it evolving? How is it likely to evolve? We try to address those three questions. Then we try to tell them how we do it, so what we are doing, how we do it, and give them some idea of why. And of course, try to relate to their experience again by saying that this may sound to be somewhat esoteric. There may not be, from your point of view, an immediate application that's just around the corner to what we're doing, but actually it has produced lots of interesting stuff which is already having an impact on your daily lives. And there we get into the spin-offs of particle physics and the developing of the technology that we use to do the subject or to do the fundamental research. Try to give them, especially young people, handles. Very often I meet young people at the end of a visit. Maybe I'll be giving them a cloud chamber workshop, or I'll just be meeting them because I know the teacher. And sometimes I ask them, try to do it in a non-challenging way, what do we use magnets for at CERN? Very often I get the classical answer, which is to accelerate particles. And this is when I know that maybe we've been talking in too much detail when they've gone to the superconducting magnet test facility and we haven't related to their curriculum, because I believe that in many countries in the world, Lorentz force is in the school curriculum, so that something that they know is fundamentally important for CERN. And without it, we could all go home. Magnets are used in particle accelerators and particle detectors. And I usually give them a handle there when we've explained all about it, charged particles moving in a magnetic field, experience of force, etc. I say, this is so important that we have a special handshake at CERN. And so I make, with my thumb, my forefinger and my middle finger, a coordinate system, and we shake hands. They remember this. And it's quite funny, because if they see me at the end of a visit and I say goodbye and I want to shake hands with them, they all start shaking hands with the three fingers. Another example of this as well is when I'm talking about the three questions, I say that somebody told me that Woody Allen reminds us that, in fact, humankind's been asking a fourth question for a long time: what are we having for dinner tonight? And there, I say, we can't answer that, they can answer that. Why do I tell them that? Simply because not long ago a group visited CERN, the class science representative wrote to me and said, thanks for a great visit, P.S. don't forget what are you having for dinner tonight. I concluded from that they had remembered the three questions because of the fourth. So try to give them things that they can associate to. Teachers are hyper important people. We have 1,100 teachers that we invite to CERN every year for between 3 days and 3-week programs. We have 1 3-week program. Most of them are one week. Why do we do this? Because teachers are our partners, our colleagues. The message we're trying to give them is that we know that they have the future of science in their hands, and without them, there will be no CERN, there will be no NASA, there will be no scientific engineering development. That's it. We try very hard to give them this message, to inspire them and empower them to inspire and encourage their students to be interested in science and engineering. We know that not everybody will go in that direction, but at least it will be very positive if they have some idea of what science and engineering is all about. When we do workshops, we try to use an inquiry-based approach, which is let the students do things. Try to tell stories about what they're doing when they're building cloud chambers. Tell the story of Wilson building his cloud chamber, Hess flying his balloons to great heights, discovering cosmic rays, or at least confirming that cosmic rays come from the cosmos, that the thing that they're building was used by Anderson to discover antimatter, for which he won a Nobel Prize, which led to the bubble chamber, which was also a Nobel Prize, etc., etc., etc. And essentially give people, when they come to CERN, a palette of possibilities. Show them films or animations, talk to them, make presentations, reinforce by showing. We are fantastically lucky at CERN, really lucky, because we can actually show them the real thing. And if you came today, I could actually take you 100 meters below ground, and you could stand and stare or look in wonder at the experiment, one of the experiments that discovered the Higgs boson. Okay? Try always to balance the explanation that you have at the site as well, not too much writing that people have to read, not too much stuff that obscures the real thing, because we are in a lucky position because we have the real thing. There's a tendency to want to obscure the real thing, and even though the real thing might look a bit dirty, might look a bit as if it's been cobbled together, it is the real thing. And if you tell a nice story about that real thing, people will go away in wonder. What we're trying to do is plant seeds with people, really. Plant seeds, especially with young people, so that when they go away, they want to know more. They are curious and they want to know more, and to empower the teachers to be able to help them to know more. I think that's about all I want to say right now. I haven't given you much details about what we do, but I've given you more an overview of our philosophy. It's not easy to manage that. We have 400 guides. They all come from all different countries. Getting this message over is a little bit challenging, but when you see it in operation and when you see that it works, it's very, very rewarding when you see young people's eyes light up and they go away from CERN enthusiastic and excited.
That's brilliant. Thank you so much. It's Penny here. I just wondered if anybody on the call wanted to come and visit you at CERN. Is that possible?
Of course. Of course. And I will take them. I will personally take them underground at the compact mu and solenoid experiment, and we can have a look. Okay? So just send me an email. You will have my email at the end.
That's lovely, thank you. And if anybody...
But only until this time next year, because this time next year we will be closed because the LHC will be starting up again, and it will not be possible to go and see what you can actually see today.
Okay, brilliant. Well, there's a challenge for you all to get to Switzerland before then, should you wish. The other thing I wanted to just ask was if the centres are talking with their visitors about how they might visit CERN. Obviously, there's the getting there issue, but can they say just check the CERN website and you'll be able to tell them this
you just go to the CERN public website, and at the bottom there's a thing that says visits, and then you just follow the instructions. But if you're thinking of coming to visit, think well in advance, because as I say, we have 100,000 a year, so that's quite a lot a week.
Okay.
That's great, thanks. I pass over to Michaela now.
Mm-hmm. Okay, so that was good. I wonder if anyone at this moment, maybe two people, have any specific questions they'd like to ask now. Obviously, we can go into a bit of a deeper discussion after the speakers, but is anyone with a question now? Okay, well, I guess I had kind of maybe one thing that might get people's juices flowing for the discussion. And Mick, if you had to say in one sentence what the LHC does, what would you say?
I would say it tries to help us to answer those three questions that I talked about, and try to say, people have been asking these for a long time, and we're still asking them, and the LHC can help us to find the answer.
Brilliant.
And can you just say something else about, so it's closed at the moment, could you just say, you said about next year, what's the plan?
Okay, so next year we're closed at the moment because it's a shutdown period to do maintenance and to do upgrade work and to install equipment which will allow us to go to the design energy of the accelerator. So in fact we'll approximately double the energy of the accelerator, and it will start to come online this time next year, and will probably be operational at the beginning of 2015. But as soon as the accelerator is kept at 1.9 degrees Kelvin, it's full of liquid helium, and as soon as it starts to be filled again with liquid helium, then all visits underground are not allowed anymore for safety reasons. Okay.
Great, and liquid helium is obviously very important in particle accelerators. Are we going to run out of it in 50 years?
I don't know the answer to that one. You get helium from natural gas, actually. So we actually hold a significant fraction of the world's supply of liquid helium sitting in tanks on the surface now, and in the accelerator when it's actually running. But I don't know what that percentage is.
Okay, because just for everyone on the call, this is an issue, and some of our shops actually do sell helium balloons. So we're actually, and as I understand it, helium escapes straight out of the planet, as it were. So I know you might all want to read up the stories about what we use helium for and why there's issues with the usage that we currently have for it, which is, given it's so important to medicine and to science. Any other questions?
Oh, okay. Thank you, Mick. So our next speaker is Claire Harvey from SEPNet, and she's going to talk to us about the CERN at School project. Basically, this is very interesting. Hopefully you've had a read of the summary that I sent round. Apologies for the lateness of that, but Claire, maybe you can just go through that. And then potentially we'd like to hear your views on whether or not anything about this would be useful for you guys. So, Claire,
Can I just bump in? This is Jenny. I need to leave now from Intech. So goodbye, everyone.
Okay, cool. Well, we'll send you the recording of this. But thanks for joining us.
Thanks.
The caller,
Jenny Shipway from Intech,
has gone.
Sorry about that. Okay, Claire, would you like to start?
Hi everyone, so as Michaela said, I'm going to tell you a little bit about the CERN at School project, which, as you can probably guess from the name, is mostly aimed at schools, but there's various areas where it might be of interest for science centres, either for your public audiences or for the work your education team to do with schools. So Michaela circulated a little summary. It's quite a complicated project in all, because there's several different branches of it. So hopefully the summary will help kind of clear some of that up a bit. But essentially this project was a student-led project from a school in Kent called Simon Langton Grammar School. Some of you may have met Becky Parker before, the teacher there. And so they designed a cosmic ray detector to go up on a satellite called LUCID, which stands for Langton Ultimate Cosmic Ray Intensity Detector. And this payload uses the Medipix chips that are in several of the detectors at CERN. I can't remember off the top of my head exactly which ones. I think it might be Atlas and potentially CMS. So these little detector chips are about a square inch with lots of pixels on them, and each of the individual pixels can detect the radiation going through it. So this payload will be going up into space, hopefully in December, which will give us data coming down for about March, April. And they received an STFC large award to go towards the educational structure and making this available for all the schools in the country. So there is a website, or at least there will be a website, where all of this data will be filtered directly to, that all the schools in the country can access for free to do their own scientific research with. Alongside that, the pupils also acquired some of these chips from CERN and started using them on the ground at their school. So in a couple of years ago now, this started. So they had 10 based in Kent, and at this point, SEPNet, my consortium of universities, bought in, and we acquired 6 as well, which we've been loaning out to our local schools to do project work with. And STFC have now bought into this idea and purchased another 25 detectors, which are now being made through an external company, which are being distributed across the whole of the UK, including both parts of Ireland, Scotland and Wales, through the Institute of Physics Teacher Network coordinators. So that brings a total of somewhere in the 30 to 40 region of these detectors spread out as a network across the whole of the UK in schools, where the kids can take their own data, do experiments with it, do longer project work, and those will be going out in September, this coming September, with the data from Lucid following, hopefully, once it's launched. So to support these, there are various educational resources that will be online on the CERN website. We're just in the process of transferring them across at the moment. They should all be available from September. with sample experiments, information on how to use the detectors, information on how to use school-based research groups, all of those kind of things. And the hope is that this will be an opportunity for the pupils to research stuff where they don't know the answer, so they can go out and do research like they would at a university and find out things for themselves. So, on the second page of the document, I put in a few things that the Science and Discovery Centres might be interested in. So, we have got an exhibit, a small exhibit for the Lucid satellite that has one of the chips bedded into it and can be used to show the radiation. So the display from the chip comes up on a computer screen as a kind of screen, and you can see the trails the particles leave behind. So there's one of those. It's about a metre square probably. It was, for those of you who went to the Big Bang Fair or the Royal Society Summer Science Exhibition last year, it was on the same stand as the LHC stand from the STFC. Big Bang on Tour stand, so they had it on the side of that. So there's a chance if you wanted to host that for a while, for a month or so, say, that we could have that rotating around some of the science centres. The Meet the Expert events that you're running as part of your Explore the Universe project, it might be an interesting one where you could have some of your local schools who are running projects come in so that the pupils themselves are being the experts and they're presenting to the public about their projects and the research they've been doing. Once we've got the Lucid data and there's data going up on this site, there's no reason why you wouldn't be able to use it with groups who come in to the Science Centre. So if you've got education teams who'd be interested in running workshops for pupils or for the public on using this data, then we could train you up to use the data and some basic activities, so you could kind of run an introduction to them on using it, in the hope that when the schools go back to their classes and things, that they might be able to keep doing it. And kind of anything else you can think of, really. It's a bit of an open-ended suggestion, so whatever you think might fit in well with what you're already doing, any opportunities that you'd be interested in would be great. I think that's me done.
Oh, great, brilliant. So has anyone got any questions or suggestions or anything at this point?
I have.
Oh, go away, Matt.
It's Penny here. And also, because this is quite a complicated project, I just wanted to say to everybody on the call, if they've got any questions of clarification about what the project is, then please do ask them. So, can you just tell me the data that comes out of what does the data look like that will come out of these detectors? Is it in graphs or numbers or pictures or...?
You can get it in a couple of formats. So the raw data comes out as a giant number data document. It will display on the system as a picture. It's a little hard to describe. I can send a screenshot around to everybody afterwards, but it's kind of a black screen, and you can see the particle trails go across, and the colour of the trail is correlated to the energy it's deposited on that pixel. So the whiter it is, the more energy it's deposited, so you can tell the energy. So if you have a really big blobby section which has hit out several pixels, has reasonably high energy, particularly in the middle, that's probably an alpha track. Where you've got slightly longer ones, a few centimetres, slightly lower energy usually, then they tend to be betas. You get lots of individual dots that tend to be the gamma rays because it's only 1 pixel thick. If it's coming in a perpendicular direction to the chip, there's slightly less you can tell about it in terms of the difference between the rays. If it's on the right angle, sometimes you can see like muons and things that travel in a nice straight line across the trip. So there's an element of particle identification you can do with it, and there's algorithms they can do. So it depends how advanced they want to go. They can just use the pictures, they can count the number of alphas and betas they see, they can count the number of total activity there is, they can look at the energies and do that manually by hand. If they're a bit more advanced and want to do a bit more coding, or say you want to run a coding workshop to support it, then there's a little bit more they can do in terms of pulling out the data and translating it into a way they'd like to see it.
And what sort of age students do you think this is applicable for?
Mostly secondary. We're expecting the project work to be mostly A-level students, but there's certainly things that year 9, 10, 11 students can do with it, probably advanced year 7s and 8s, but probably less kind of open-ended project work. So there'll be some experiments on the website that they can just work through, and those would be suitable for Key Stage 3 or 4. There's other projects that will be running from other schools that they could get involved with. So, for example, Simon Langton have set up a project called Radiation Around You, where they're trying to get a background radiation map of the UK that they can then match against geological mapping. And so they've developed a protocol of, what data you have to gather in what conditions, under what settings. So there's no reason that younger pupils couldn't gather that data and submit it through to the wider project and things like that. And other schools may develop similar projects where many schools can get involved in submitting data.
And are you happy, Claire, for anybody on the call who thinks they might be interested but isn't quite sure of all the detail of it, or maybe doesn't know that much about particle physics and needs some help with that, to get in touch with you?
Yeah, that would be great. Anyone who's got any interest in any of it at all, do get in touch with me. I can come out and see you if it's going to be easier to go through things in person, or we can chat in more detail over the phone about the options, and I can send you more resources. Once the resources are up on the CERN website, at the moment they're behind a password on the Simon Langton website, but they should be up within a week or so, and I'm happy to send that around to everybody when we've got that, so you can have a look at the resources and the kind of things that will be available.
That would be great. I imagine, I could be wrong about this, but I imagine within our network it's partly the feeling confidence in the content as much as anything else.
Yeah, and if you wanted to use some of the data or have a workshop with some of the data, we'd provide as much training as you needed. What we did for the teacher network coordinators who are using the detectors is they came in, they had a full day's worth of training. RAL actually have one of these as well, and Daresbury are going to be getting one. They came in, they had a full day's training. They then took it away, and they've spent the last 2 or 3 months using it themselves without taking it into school to gain their confidence. And through that time, they've had one-on-one support from our technical manager to sort out any glitches and answer any questions they've got, so that they feel confident with it before they take it into school. So, we can arrange training to suit, and then some one-to-one support to make sure that people are happy with it before they have to start running sessions.
That's great, thanks.
So is anyone who would be interested, who's on the call right now? Obviously we can ask others, but who would be interested in a sort of a training thing, if there is any way we could possibly arrange that? Who might be interested, and in what form would you be interested in seeing that? Anyone want to jump in? Yes, no?
Yeah, I think Stratosphere would definitely be interested in any sort of training like that. Format-wise, it would be great if it would be hands-on with using the equipment and manipulating the data to make it something that could be incorporated into a workshop that would be interesting to pupils.
Yeah. Okay, anyone else?
At Glasgow Science Centre, we actually have somebody collaborating with us on the Coder Dojo project, and he runs coding workshops for school children, and I'm sure that he would love to be involved in using the data from the Lucid exhibit and translating that into different formats.
The other thing to say about Glasgow is, so the chips they use, these Medipix chips, are used for other things as well as CERN. And if a university wants to use them, they have to buy into the Medipix collaboration, which costs €300 a year to be part of. And Glasgow is actually the only university in the UK who are bought into the Medipix collaboration. Okay. So there is a group there, I think, in their particle physics department, although it could be in one of the other research groups, who have a lot of these detectors as well and work with them regularly. So there might be other links for Glasgow that could be made with the local university.
Okay, excellent.
About the detectors.
Anyone else?
Will there be a database of the schools that are involved in the project available online?
Probably not just out there for anyone to look at, because it would be just a data issue. But if you wanted to know which ones were local to you, I could certainly put you in touch with them.
Okay, that'd be great.
And Claire, would you be willing to travel up to Scotland, or would they need to come to you?
I think it would be kind of a bit of a give and take, and depending on what the level of interest is. If we've got a few people and it's, 2 or 3 of you to one of me travelling, then I'd come up to Scotland. If it's one of you and there's a lot of people in the south who want it, then we might look at bringing you down, but we might be able to find a bit of money to help you get down, if that makes sense.
That sounds good. Well, why don't, if any of you want to have a think about it or ask more questions and before you decide if it's something for you, and then maybe Michaela can
I'll try and
summarise who's interested.
Yeah. But obviously,
Can I just add one piece of information?
Yeah.
Okay, just before I came to this meeting, I went downstairs because I know somebody who has one of these MediChip kits, actually. They're being commercialized now. They're being developed by 4 different companies. The one that I saw was one that's being developed by a Czech company called Jablotron. And they're very neat. They're coming in a nice box. They're very small. The chip itself is the size of a thumbnail. It has connected to a computer, etc., USB connection. Comes with software. Problem is, it comes with a price tag of €3,000 at the moment, which is a bit prohibitive for many schools, certainly in Europe. But one interesting thing I did find was that the company Jablotron, www.jablotron.com, have a website, and they claim that they will be putting on their website descriptions of 15 experiments that you can do with these MediChip chips. I went and had a look. There was only one demonstrating how you can show that alphas are absorbed by water, which is a nice little experiment. But maybe if you watch that space, you will find 15 experiments, some of which you may not have thought about. Certainly I will look, because I will certainly have not thought about them. Okay?
Jablotron's who the latest order that we got for the STFC, so the latest 25 were bought from Jablotron.
Okay.
Thanks. Maybe you can send us that website, send it to Michaela as well, and we can put all of this, anything from this call, if you can send it to Michaela within a week, and then she can pull it all together and send everything out.
Yeah. Any more questions, comments, or shall we move on? Alrighty then. So next up is Elizabeth, who works at RAL, and she's going to be...
I don't work at
sorry.
RAL.
Where are you based? Harwell? No.
No, I'm based at the University of Surrey.
Oh, sorry, my mistake.
I'm connected to the Swindon office.
Sorry, I've obviously got my lines mixed up. Anyway.
I think Sophie was originally going to be able to do this. Sophie Palmer was She does work at RAL.
Sorry about that. Okay, so Elizabeth's going to talk to us about some of the particle accelerators in the UK and how they're used, ways that you can link up applications and so forth to some of the experiments you're doing. So, Elizabeth?
Okay, hello everybody. It's nice to speak to you all. So I'm talking on behalf of Sophie Palmer, who couldn't make it today, about the applications of particle accelerators. As Mick was saying, it's important when you're talking about these sorts of experiments to give the students hooks that they can identify with in their everyday lives. And most people, when they think of particle accelerators, they think of them as these rare things that do these complicated experiments, replicating trying to simulate the Big Bang or the conditions in stars, and they don't think about how they affect their everyday lives. So there are lots of practical applications for particle accelerators that you can relate to if you're doing these sorts of sessions in your science centres. So particle accelerators are used to study materials, to understand the structure at the atomic level or the subatomic level, and that is useful for all sorts of things, for studying proteins, biological processes, viruses, also for developing new drugs to treat diseases such as cancer, diabetes and malaria. Most people will have a silicon chip in a smart device that they have on them, and that may have been implanted with ions using a particle accelerator. They're very important for making chips in compact electrical devices. Also, cancer therapy. So sometimes the best way to treat cancer is using a particle beam, and thousands of patients a year are treated across the world using particle accelerators. Hadron therapy, proton and ion beams are used to treat deep tumours. And also they may have heard of medical diagnostic treatments, so things like PET scans, positron emission tomography, where the radioisotopes used in PET scans are produced with accelerators and are used in other types of medical diagnostic and treatment. And then as I, in a previous life, I was a nuclear physicist. Particle accelerators can also be used in nuclear energy. They have the potential to treat nuclear waste, to enable them to have a shorter half-life, to be cleaned up more easily, and also for more conventional types of energy production. So for coal, any type of energy production that has puts out a lot of pollution into the atmosphere, it can be used to kind of moderate that emission and to check the amount that's being released into the atmosphere. And then there's a few random things as well I found when I was researching this. So particle beams are also used to non-destructively treat works of art and ancient relics. And we actually have an ion beam centre on the campus here at Surrey. Our museums send paintings to be investigated using the particle accelerators to find out what the paint is made of, and then they can figure out sort of where those paints came from. They know where the painting was painted. They can figure out where the ingredients of the paint came from and where the trade routes were in ancient times. So there's lots of interesting things that can be done using particle accelerators. And I found there's an organisation called Tiara, and I can pass that link on, which are very into promoting the applications of accelerators in everyday life. So they have some quite good posters and resources that might be useful to those who want to find out more. Now, another misconception about particle accelerators is that they're very rare and that there aren't that many of them. And I haven't been able to confirm a more recent number, but there seems that there's over 25,000 in the world, particle accelerators, and in the UK there's over 150. Some of them are big research institutes like you would associate with CERN, but others are smaller. There's a lot in hospitals that are used for these sorts of treatments and diagnostic purposes that I've spoken about. The UK's largest particle accelerator is on the Rutherford Appleton Laboratory Campus, the SDFC-run Rowell campus, and that's the Diamond Light Source. And that's a synchrotron particle accelerator. And what that means is it accelerates electrons close to the speed of light, and as they're circling around the accelerator, they give off energy in the form of highly directional beams of light. And this light can be anywhere from infrared to ultraviolet light, and also beams of really extremely intense X-rays. And they have, I visited there in July, and they have all sorts of experiments going on targets that come off this beam. And they do work in new cancer therapies, ways to clean up polluted soil, improving the efficiency of hydrogen storage, which may be an option for a sustainable energy source. And they do things in diseases like foot and mouth and vaccinations and all sorts of things. So that's going on in Oxfordshire, not that far away. And then they also have at Rowell the ISIS particle accelerator, which is one of the world's best sources of neutrons and muons. And they also have health and environmental applications that come out of those particle accelerators. So the science is not only happening, everyone's heard of CERN, but there are also world-leading particle accelerators in our country. And then at Daresbury, which I visited on Monday, so I'm just learning about Daresbury, they have a Centre for Particle Accelerator Research, and they're developing prototype accelerators, trying to reduce the cost, trying to make them more efficient, so that particle accelerators in hospitals can be less expensive, so maybe they can have more, so they can cut waiting times, and they really have a very good group there which researches prototype particle accelerators. I don't know if Wendy probably knows more about the Daresbury particle accelerators than I do, so I don't know if she wants to chip in at this point, Wendy or Alan.
No, I'm all right actually. I think Alan supposed to have told you a little bit more in depth about the technical side of it. He's just had to leave, I'm afraid.
Okay.
But we can always get that information to you quite easily.
The two accelerators at Daresbury that I learned about on Monday were Alice, which is accelerators and lasers in combined experiments, and they're researching new cancer treatments, and they also provide source of electrons for other accelerators. So there's also Emma at Daresbury, which is electron model for many applications, and that's what's looking into more efficient processes for accelerators to make them more compact, cheaper, and deliver beams in a more controlled and accurate way, which would be very promising for hospitals, reducing waiting lists and making treatments more effective. And also it can be applied to nuclear reactors and nuclear energy and make waste less hazardous. So that's all I have to say, but I have lots of links and things if anyone wants more information on any of this, and I can send those to Michaela so she can include those in the information. That's me done, thank you.
Thank you. Great. Has anyone... Well, actually, we'll be moving into our open forum and discussion. So most of you sent through top tips and questions, and I've got the questions written down. So maybe we'll start with that. But I suppose first, does anyone have any questions based on what they've just heard?
No, I mean, I just thought it was a really good overview of some of the particle accelerator things going on, and if we could get the links, that would be very, very useful.
Sure, yeah. There's a lot of information I just hurled at you, so you might want to digest it in your own time.
Absolutely.
Has anyone, so people who have been doing Explore Universe activities thus far, have any of you found any particular applications or ways that accelerators have used that people have been especially surprised by, or is anyone?
I know in Oxfordshire, people are generally surprised that we have one nearby. When we say, it's the big silver donut that you see on the A44, oh, really? So knowing the local ones and the local bits and pieces has been quite useful to be able to say, 20 miles down the road or whatever, there's one of these great big whacking things. It's been quite nice to have a local angle for us.
Okay.
And can I just ask, if people, for example, the people on the call at their centres wanted to say to their visitors, you can go and visit one of these, all you do is phone up or check the website, or what would they be saying if they wanted to visit Daresbury or anything at RAL to tell their visitors and teachers? Sorry.
Daresbury and RAL do open days, so this is Elizabeth. Do open days, and I believe that on the STFC website they have the contact details for how you arrange visits to these sites. So if you were to Google Visit Daresbury Open Day, then the relevant contact details would appear on the STFC website.
That's great, and perhaps we can put something on the Explore Universe website as well, linking it all. Because we're one of ASDC with our partnership with STFC, one of the things I think we really should be promoting or want to promote is that students and teachers and families can actually go to these things. They're based in the UK, they're doing amazing world-class research, and I think sharing that with visitors and saying, no, really, you can just actually go and walk around one of these amazing particle accelerators and find out more, and here's where they are. So we could, do promote that with your centres. There is material that STFC has that talks about this.
Yeah, I think there's already a post on the blog that I believe one of STFC's interns put together, which brings together a whole bunch of resources, and we are working on one about how you can sign up to every single relevant newsletter, journal, whatever that's out there. So that one's coming in a couple of weeks, hopefully.
That's great. And is anybody anyone from any of the centres working with any of the particle accelerators or celebrating any of the work they do at the moment?
Hello, this is Mick again from CERN.
Hello.
I'm sure you're going to put on your website how to visit CERN, and one thing to know, it's absolutely free of charge. So I know it's difficult to get to CERN, but in fact maybe it's less expensive than getting from Glasgow to London. I have no idea if you take EasyJet.
Yeah.
One of the things that you can do at the moment is you can actually walk inside an accelerator, which is operating as a decelerator, because we have an antimatter factory at CERN. Dan Brown was right, we do make anti-hydrogen. But to do that, we have to slow down antiprotons. So we have an accelerator which operates as a decelerator. You can actually walk inside that, and you can even touch the elements of it. And at the same time, if you're close to that, you can go and look at the start of the whole chain, which is a bottle of hydrogen, which the protons disappear down the LINAC, etc. There's a whole chain of accelerators, one of which, by the way, is more than 50 years old. Another nice message for young people is that this accelerator was commissioned in 1959. It's still running today. And the guys who built it and designed it didn't have any digital computers to help them. They didn't even have pocket calculators. They did their calculations either in their heads or with slide rules and logarithmic tables. And it's still running. And you can see another one, which is the low-energy ion ring, because we accelerate lead ions as well. And you can look at that ring as well. So there's again, it's real stuff that you can see. I've been to Diamond. I was very impressed with the Diamond facility. It was very shiny and it was bright, as you would expect a diamond to be. When you go to this part of CERN, which is the old part, more than 50 years old, it looks a bit, but it's extremely important for the operation. The LHC couldn't work without it, and of course it is exciting to go and visit the antimatter factory.
It is. Okay, so should I maybe start off by throwing in a question that Jenny, who unfortunately had to leave, she asked me if we could ask. This one's quite specific to our salad bowl particle accelerator, and this is for all of you basically, because you've all hopefully been using it. And she's going to be using it for the first time with the public herself personally on Saturday, and she just wanted to know if there are any top tips or things to avoid with the salad bowl particle accelerator. I don't know, maybe Sophie, throw it to you first, and then because you've just been at Green Man showing everyone this, so.
Yeah, absolutely. I mean, I think one of the key things, especially if it hasn't been used for a while, is to make sure that the actual bowl itself is clean. So it's worth giving it a good wipe down on the inside. If you've got something like propanol or cleaning alcohol, that works really well, especially on the strips. Because if any sticky material's got on the strips, that's going to impact the ability that it's got to attract and then repel the nickel balls. So from just a logistical point of view, making sure the bowl itself is nice and smooth and free of little bits of stuff is particularly useful. And the same for the top of the Van de Graaff. The cleaner it is, the better capacity it has for building up the charge. So it's quite important to try and keep it as free of bits of stuff as you can.
And have the others of you used the salad bowl? Is there anything you'd want to share about the way you communicate it, the way you talk about what's going on?
I have a tendency to actually not use it to talk about particle accelerators that much. I sort of use it more to talk about charge, specifically sort of on how opposite charges attract and similar charges repel, and so I sort of just use it as a physical demo for that. So I don't really relate it that much to particle accelerators per se. I sort of use it more to talk about the basics.
Yeah, I suppose as well there is that caveat that modern accelerators don't accelerate their particles in the way, or in the opposite way that the bowl is actually showing itself, so it can get a bit tricky, I guess. Has anyone else got any sort of...
Well, we at Dynamic Earth, this is Tiffany, when we are using our Van de Graaff generator and particle accelerator, particularly for the younger children when you're introducing particle accelerators for the first time. They may never have heard of them before. And talking about how scientists and engineers use waves to learn more about the universe. Using that, rather than talking at them, using that as just a really simple model to get them up and standing around to break up the chat a bit, and then to talk about the differences between our model, the particle accelerator in a salad bowl, and what real scientists and engineers use in bigger particle accelerators, how they actually use the waves that we've been learning about, whether it's the field, whether it's magnetic fields or electric fields. It's just a really good model for being able to talk about something that's really tricky to understand, particularly for the younger groups. It's just a good way of talking about the different fields that we've been talking about and how it's applied in real life.
And if I can just jump in again, I'm sure everybody's been checking on the Explore Your Universe website and looking at the resources that have been put up. But I've recently put something up there about using X-ray scattering from synchrotrons and how it was used to discover DNA, so that includes PowerPoint and things. So if anybody's wanting to be able to link it to a biological application, there are already some things up on the website about that as well.
Cool. That's great. We've only got 10 minutes left, so if you have any burning questions to ask what a muon is, or something to do with how you see quarks, or whatever you want to ask, now is the time.
Speak now or forever hold your peace. Well, maybe not.
So some of you have asked questions in your booking form, so just ask those now.
If I could ask Mick, actually, similarly to the question I put in the booking form, he mentioned that when the visitors meet some of your geeks, them being a scientist or an engineer can be a strong point but also a weak point. Could you elaborate on that further and maybe give us some tips on how to rein in plastic particle science in case they alienate their audience?
Well, yeah, I mean, it's difficult really, but we do give them training. All guides, anybody that wants to come to wants to be a CERN guide, we do give them training in basic communications, and this is one thing that we talk about. Very important that they are a geek, that they tell people, that they are a geek, not like this, tell them where they work, etc., but not in a disparaging, not in a patronizing way, but just say, it's really saying, I am a real scientist. The difficulty is that these people then often jump into a level which is inappropriate, but we cover this in the communications training as well, and every time it's a hands-on communications training, they have to talk, they have to stand up and present, and they get positive feedback from the team, and some remarks from me. If they start using acronyms, if they start using things that we as members of the general public would not understand, we highlight that we rigorously highlight that and say, really you have to think about what your audience want to know. This is one very important thing. We start off by saying, why does CERN want to invite visitors? Why do people want to come? And we make a list of why do people want to come, why does CERN want them to come, and say that the guide always has to keep those two lists in their minds and try to make the overlap between the two. It will be different depending on each group and each individual, but there are some very important major things that we want them to say. And for example, one thing at the end that I didn't say is that I try all the time with a school group to insert the following, that you don't need to be Peter Higgs or Stephen Hawking to have an interesting, exciting and useful career in science, engineering and technology. Peter Higgs could not build the LHC. Stephen Hawking would not know where to start to build the CMS detector. This is done by thousands of people. They're all doing different jobs. They all have different skills. And the people in front of me, I say to them, there is a place for you. And sometimes I do this at the AMS experiment, which is controlling the AMS detector detectors attached to the International Space Station. I say to them, you can even be a brave astronaut if you wish, or design the suit that the astronauts wear. I try to tell them that there's something that they can do. They have to get the idea it's not beyond their reach.
The caller,
Brian Mackin,
has gone.
Hi there, thanks. Sorry, somebody slipped off the call, intentionally or otherwise. Can I just ask if, since we have you on the phone from CERN, could we, Mick, could you just, if you had to say what the very latest on the Higgs was in a couple of lines, what would you say?
I would say that
to a 10-year-old,
instead of discovering a Higgs-like particle, they have discovered a Higgs particle. They don't know whether it is actually yet the Higgs particle because there can be several, and they need more data to be able to establish the properties. So they're still analysing the data, but they will get much more when we come online again. So it's definitely, when they announced it on July the 12th, it was a Higgs-like particle or a Higgs particle, but we don't know whether it is the Higgs particle that we're looking at. It could be one of the others. So they have to do some more measurement. Okay? So watch this space.
How exciting. And are there any insider juicy stories that are everyone...
Brian from Science Oxford.
Hi Brian, welcome back.
It's interesting that when you say this, because in fact the experiments don't actually talk. One thing that's very important to say to people as well, that a single measurement is not a discovery in science, and so that's why we have two big experiments, discovery experiments, CMS and Atlas. If they both say they've seen the same thing, then we're pretty confident that they are right. If one of them said they had and one of them said they hadn't, there would be a lot of hard searching and a lot of tests would be done. But essentially they don't speak to each other. The experiments are completely independent. They use different protons, same accelerator, different detectors, and they really do not make public what they are going to publish until they publish it. And then they inform the Director General, and then the Director General will ask the other experiment, have you seen the same thing, etc., etc. So obviously rumours sometimes circulate, but it really is... they're friendly, but dire competitive.
That's interesting.
Okay, so they don't all go out and party together. They're very separate entities, is that right?
They party, and you will get invited to the CMS party when they've published their paper, and you can go and have a drink with them, but they will not invite you before, that's for sure.
All right, fantastic.
Okay. Sorry, I was going to say we have a minute left, so I was just going to throw in one last question that someone asked on the registration form, and maybe whoever asked it can maybe elaborate on what the question was more about. But someone was saying that they didn't have a quick and easy way to start introducing, for slightly younger people, the structure of atoms, and that is it's more specifically talking about why it is, you get the different effects in spectra, so emission and absorption lines and that sort of thing. I don't know if anyone wanted to maybe elaborate on specifically more on that question, or if someone wanted to answer that question, or maybe how they found a good metaphor, a good demo specifically about that.
One metaphor that's relatively commonly used when it comes to the whole idea of energy levels and spectra and things like that is literally the idea of climbing up a ladder and needing energy to be able to climb up that ladder and then jumping back down again and things like that. It is a very tricky concept when you're dealing with younger kids, because an analogy that's commonly used for explaining the idea of what atoms are is Lego. But then, of course, Lego is all just one block, and you can start trying to say that the little blobs on the top are acting as the electrons and other things that are causing it to stick together. But it then, when you start having to think about the idea of electrons being a separate orbital entity, it gets confusing. So ladders is about the best for spectral lines that I've found. I don't know what anyone else has been able to do in the past as well.
Just kind of to elaborate on that, I'm no help whatsoever as far as actually explaining atoms to younger pupils, but one of our experts that we had in, Stuart Farmer from the Institute of Physics, used LED lights to describe that, because the red LED light actually produces less energy, and so the spectral lines match that, and he had a really nice little graphic about the energy level, and the colour of the little electrons jumping off matched the LED lights, and he kind of tied it in really nicely, looking at how the colours of this LED tower all reflected different energy levels, and I thought that was a really, really nice way of kind of tying it all together.
Cool.
And I mean, if anybody's feeling particularly adventurous, I can send around a link for a chemistry-based demo, which actually allows you to use different colour LED lights to ignite a gas, and the lower energy lights won't ignite the gas, but the higher energy ones will. I mean, obviously, you'll have to look into the health and safety implications of it, but I can certainly send the link round.
Yeah.
Cool.
That would be great. I think if you can all send any links to all of you that you think you would want. I mean, Michaela can send us sort of one summary round, but don't hesitate to get in touch with each other and send things around. If you think there's other people who are describing particle physics to primary or to secondary students or to families, do make sure that we're all sharing everything that's there.
Yeah, and obviously it's easy. It's nice and easy.
Could I ask you a question?
Yeah.
Just a very quick question. I'm interested to know if there's anything that you think that CERN can provide you that we don't provide you, or so for example, we have lots of material that you can find on the web. We have printed stuff as well, which you can get from STFC. We have mini exhibition that can travel around. We can do video conferences with you. So audio conferences are great, but video conferences are much more fun, and young people can ask their own questions of a geek, a real geek, sitting in Geneva, looking as though he's in the LHC tunnel or in the CMS cavern, or it may even be in the CMS cavern. So we can do that sort of thing relatively easily. But if there's anything, or if you want to do that, just let me know. Or if there's other things that you feel that you would like, then just let us know.
Well, Mick, I would love to talk to you about doing, like a Google Hangout. So, I mean, I was meaning to ask everyone on this call if they had a kind of setup that is available to them to at least be able to watch, maybe not participate in a webinar. So is there anyone who feels they would be massively limited in being able to take part in a webinar, which may just involve getting onto YouTube? And a camera if you want to take part. Does anyone...
To do a video conference, you need a laptop with a webcam and a microphone and a projector, that's all.
Is anyone saying no?
Hello. We're not asking the question now. They can ask afterwards if they feel they want to.
Okay, well...
Mick, if some of the centres wanted to do a sort of meet the expert, and the expert was at CERN, set up a video in their science centre for 10 minutes during the Explore Your Universe show, for example.
Yeah, no problem. We can do that. You just need a good internet connection, where good means what you have in a reasonable house, actually.
Okay, great. So do get in touch with Mick if you'd be interested in that.
Yeah. Okay, well, I mean, I want to look into Google Hangouts more for the future, so that's cool. And then, maybe I can try and pull together, or with Mick I'll pull together all the various resources that are available, and then the IPOG database as well might be useful as well. So, I'll work on that. Okay.
It just reminds me, sorry, this is Elizabeth, there's a list on the STFC website of particle physicists willing to come and give particle physics talks, and their contact details. So I'll include that in the links I send as well, because you can look, there's ones from all different universities across the country, and you can see where your nearest friendly particle physicist is, and invite them maybe to come and give a talk as well.
Oh, brilliant.
There's also the Institute of Physics is setting up a database of all the physics departments in the country and the outreach offerings they have across all topics. It's in, I hope, final version of beta testing at the moment, and it should be out within the next month. So I'll pass that on to Michaela when I've got it, because then you can just get in touch with the outreach officers and book a speaker. directly through them
Yeah,
on any topic in physics.
Yeah, that'll make it much easier to find university coordinators. Brilliant. Okay. Okay, so has anyone got any final questions before we close this call? Yep.
I have. I'm just going to quickly jump in. So before Michaela closes, but just to say thank you so much to all of you. But also, please do share those resources. So send anything to Michaela within a week, and she'll share it. But otherwise, really do send all that stuff out to everybody, because I think there's a lot out there that each of you know about, but collectively we could all do with sharing a lot more.
Okay, well, thank you everyone for calling, and thank you to Mick, Claire and Elizabeth. To say our next call, or maybe webinar, we'll see, is on the 16th of October, same time, 3:30 to 4:45. I haven't set a theme or a subject for this yet. If you've got any ideas or any specific things you might want to talk about, then do just drop me a line. Otherwise, thank you very much, and we'll hopefully be seeing you all reasonably soon.
Great, thank you.
Thanks very much.
Thanks a lot, guys.
Bye.
The caller.
Tiffany Gillis.
Gillis.
Well done.